Yay! This is my second video about the kinetic energy of a gas. Let's say that you have some amount of gas. It could be, quite a few moles. It could be quite a few molecules. Regardless, you can find your total kinetic energy of a gas. Regardless of the amount of it, the total kinetic energy of a gas will be 3/2 times N, which is the number of moles, R and T. That's your total kinetic energy. Very, very quick derivation, and I don't want to lose you. But remember that we said that PV equals RT, right? Where N was number of moles. Okay, and R is universal gas law constant. But we also said that PV equals NAT, right? Where this time N is number of molecules. All right, and K is now Boltzmann's constant, that other constant. If we're talking about the same gas, if you kind of make the connection that these two are the same, let's imagine it's the same gas, then what you can do is say, okay, in reality, that's the number of moles times the R times the temperature equals the number of molecules times K times the temperature. The only difference is how you want to approach it. All right, if you'll follow me here as I continue. Okay, if you know that the kinetic energy of a gas is 3/2 nRT, and you also know from the previous page, okay, that nRT is equivalent to nKT, then you can also extend this definition such that 3/2 nKT is also the kinetic energy of a gas. And when I say this, I mean a total amount of gas. So we're going to assume that this is some, volume, some large amount of gas. If I wanted to ask you what is the average kinetic energy of a gas molecule, the average kinetic energy is going to represent the energy of just one molecule. Okay, this is expressed as kinetic energy average. That is very simply the kinetic energy of just one molecule of a gas. Well, we know that big N right here is number of molecules. So if we want to describe the average kinetic energy for just one molecule of gas, then you can just say it's 3/2 KT. You can imagine, sure, N is still in there. All right, so you could say, yeah, it really is equivalent to 3/2 nKT, but this is under the assumption N is now 1. You can kind of eliminate it from there and just think of it as 3/2 kT. That's a very convenient way of expressing the kinetic energy of a gas. So now what I'd like to do is to look at two questions and navigate how to solve those two questions. All right, so my quest asked me this question specifically. Find the kinetic energy of a gas when you've got 3 liters of it. It's got a temperature of 6 and a pressure of 3 atmospheres. The equation that I know, this is actually asking for the total kinetic energy. The equation that I know is 3/2 nRT, okay, or 3/2 big N KT. I do not have any of that information. I do not have the number of moles, nor do I have the number of molecules. So I'm going to have to be clever about how I think of solving this problem. What I do notice is that I've got a pressure in there and a volume. Let's go back to our original law equation, right, which is PV equals nRT. Do you see anything in this equation right here that perhaps is in one of these two equations? Well, I see nRT and I see nRT. If I look at this equation again, so let me rewrite that my kinetic energy equals 3/2 nRT. I see nRT and nRT. What if I simply take that PV and substitute in here? So I can rewrite this to like that the kinetic energy of this total amount of gas is going to be 3/2 times PV. And where did that come from? Simply substituting in PV equals nRT. That nRT is substituting straight in. And actually at this point you can solve for your kinetic energy. The pressure was 3 atmospheres. What was the problem with that? Well, you have to convert that to pascals. Essentially all you need to do is multiply 3 times 101,300. Then for your volume needs to be in meters cubed. Sorry, my kitty. Get down. Okay, so now you need to do this in meters cubed. So when you have your liters of gas, remember what you have to do is you have to convert that. And how? Remember that your 1 liter equals 0.001 meter cubed. So finally, in the end, once I substitute everything in, I'm going to get that my kinetic energy is 3/2 times my pressure, which is 303,900 pascals, Okay, times my volume of gas, which is 0.003. I'm going to pause for a second, ask you to calculate that. And the final answer is 1367.55 joules. Boom. Kinetic energy of a gas part 2 is going to be the next video.